Okay, let's look at section 10.3. This section talks about the uncountable sets, right? So we've been talking about countable sets. So what are the examples of uncountable sets, right? So here are a few examples. Set of real numbers is uncountable. Also, set of all irrational numbers will be uncountable. And also interval from, say, open interval from 0 to 1 is uncountable. All right. So let's look at this theorem. This theorem says that we need to prove that an open interval from 0 to 1 is uncountable. All right. So let's prove that. Let's prove by contradiction. All right. Let's assume that it is countable. So assume that open interval from 0 to 1 is countable. Right? What does that mean? Right? So it's definitely an infinite set. So if it's countable, then it has to be denumerable. Right? Right? So this guy must be a denumerable set. All right, so which means that we can list elements. So 0, 1, right, can be listed as, say, A1, comma, A2, comma, A3, comma, and so on. Right? So these are the numbers, real numbers between 0 and 1. So we can write the decimal notation present representation for each one. For example, A1 could be written as this is between 0 and 1, so it's going to be 0.A11 and A12, A13, and so on. Right? So each number represents a digit, right? So it's like a 0.125 or something like that. And A2 is also 0. Say A21, A22, A23, and so on. And I just keep on doing for each one, right? So if you can list all the elements in between 0 and 1, so it's all real numbers between 0 and 1 in this fashion, right? And it would be a contradiction if we could find an element between a real number between 0 and 1 which is not included in this list. All right, so let's try to construct that. All right, so here's the construction. All right, let's define a number b, which is between 0 and 1 by this way. All right, so b is going to have a decimal notation. So it's going to be 0.b1. So b1 is the first digit, and b2 and b3 and so on, right? And we're gonna define each digit this way, right? So we want to make sure that the first digit b1 is different from first digit of a1, and the b2 is different from the second digit of a2, and the b3 is different from the third digit of a3, and so on, right? So we say b1, let's say, is defined to be, bi is defined to be, let's say, 0 if ai is equal to 1, right? Then bi is equal to 1 if ai is different from 1, right? So all I'm doing is that I'm setting bi, make sure that it's different from aii. If aii is 1, put 0. If aii is not equal to 1, put 1. So note that bi is always different from aii for all I natural number, right? So which means that we could make sure that the b is always different from any of these elements listed here, right? So which means that the b is not included in this list. A1, A2, A3, and so on, which is a contradiction because b is a real number between 0 and 1, and it's supposed to cover that if we assume that this set is a denumable set, right? So therefore it's not denumable, but it's infinite, which means that it's an uncountable set. So therefore, right, 0, 1 is uncountable. All right, that's it. I hope that this was clear.